Hello everybody. Today we start with a new chapter in maths for standard 8th ICSE, and that is mensuration. As I am aware that in your school they have started directly or they have skipped the first two parts of the exercise, that is 18.2 and 18.3. Sorry, 18.1 and 18.2, about the two-dimensional figures, that is squares and triangles and all. So we will directly move on to the three-dimensional figures, and that too only the one which are the cubes and cuboids. So the volume and so 18.3 exercise is based on volume of the three-dimensional surface. That is any kind of a box or normally the box will be the shape of a cube or a cuboid, right? And we will also be having the 18.4, which will be based on the surface area of the cube and the cuboids. So we'll be having only in this particular video we'll be having only the volume part. So the volume part of the cubes and cuboids will be learned over here. So first thing is, let's understand what is the difference between a cube and a cuboid. So if I take a cuboid will be such that if this is one of the face of the cuboid, then it will be seen that it will be a three-dimensional figure such that this is the length, this is the height, and this is the breadth of that particular cuboid. And here the length, breadth and height are not the same, or may not be the same. So if it is a rectangular kind of a box, okay, if you are having a rectangular kind of a box, we call it as a cuboid. You can see over here the thickness is less, that is the breadth is less, but the length is bigger. Height and length, we can say it is quite the same, but yeah, it may be different also. So this is the cuboid. Whereas when you talk about the cube will be the one in which the length, breadth and height all are the same. So if it is a square over here and this is also going to be a square like this, and accordingly a square like this. So the length is also A, the height is also A, and the breadth is also A. So when the length, breadth and height, so that is, this is the length from here to here is the length over here, the breadth is A again over here, and the height is A over here. So if the length, breadth and height all three are the same, we call it as a cube. Whereas if the length, breadth and height are different, we'll call it as a cuboid. It is not necessary that all length, breadth and height, all three may be different. It is possible that you can have a square cuboid where the length and height is the same but the breadth is different. Possible, quite possible. You can have the length and the breadth be same but the height is different. It's always going to be that way. So accordingly, the volume of this is given by volume is equals to length into breadth into height. Okay, now since over here the length, breadth and height all three are same, so we can say A into A into A. So the volume over here will be equal to A into A into A, which is nothing but A cube, or we can write it as or side cube. Okay, so the volume of a cuboid will be length into breadth into height, whereas the volume of a cube will be side cube. Now, if this is in centimeters, all three in centimeters, then the volume will be in centimeter cube. And if all of them are in meters, then it will be in meter cube. So, depending upon where sides given to you are in centimeter or meter, you are going to have the cuboid volume will be in centimeter cube or meter cube. In case some part is given in meters and other in centimeters, you need to convert all of them into the same unit. So if you either convert the meter into centimeter or you convert the centimeter into meter, so that your length, breadth and height should be of the same units. Okay, only if they are the same units you can calculate the volume. If they are not in the same units, your answer will go wrong. That's why the volume, the units of volume are centimeter cube or meter cube. Same for cube also, it will be centimeter cube or meter cube. So the volume is going to be found out as volume ka units will be centimeter cube or meter cube. also given as cubic centimeter or cubic meter. So, okay, so if in the word problem they are given you the volume is this much cubic centimeter or cubic meter, it is the same as centimeter cube or meter cube. So you should not get confused about the fact that what is given over there. So since the cylinder part is not there in your syllabus or your school, so I will just skip that part, and accordingly we will just start with the numericals, or that's a word problems, or you can say the exercise 18.3. Now I can see that out of the 18.3, only the first 6 questions, okay, even the 8th one is the one which is connected to the cubes and cuboid. So since there are only 7 questions, I will better do all of them and not keep anything as your homework. So your homework will be doing all the solved examples which are here. So the solved examples related to the one which is cube and cuboid will be up to that will be up to example number 5. Okay, so example 1, 2, 3, 4, 5 are your homework which you will be need to do, and also example number 9 and example number 10. Yeah, example number 9 and 10 will also require to be your homework. You can just check it out. Yeah, so your homework will be example 1, 2, 3, 4, 5 and then it will be directly 9 and 10. 9, 10. I think you can do also 11, 1. 11th is also quite easy. So yeah, you can do this. Now another important thing what we need to understand over here is that you can see that this is the base. Okay, this is the base of the box. So you can see that this L into B is nothing but the area of the base. So that's why we can also say volume is equal to area of base into height, or we can say area of cross section into height. Like if it is a tank and the tank has got a square base, then area of cross section will be the area of the square into the height of the tank. Okay, so such sum is the one which is this example number 9 and example 9, 10, 11 are the one which are connected to such a kind of a sum which is based on the volume which is given by the formula, not length into breadth into height, but area of the base into height or area of cross section into height. So understand that thing properly. So we'll start with the exercise 18.3 first. So to start with, the sum number 1, the volume of a cube is 343 centimeter cube. So what's given to us? First of all, what is required that as soon as we read the sum, we should be able to understand what is the data given to you. Okay, the data given to you is the most important part. So here it is given to you that the volume of a cube, so it's a cube whose volume is 343. So it's given that volume is equals to 343 centimeter cube, and you need to find the length of the edge of the cube. So we know the formula for volume. The volume of cube is equals to side cube, or better just write over here a cube. So that means 343 is equals to a cube. So what we'll do, we are just going to do the prime factorization of this, because a cube, if you know that 343 किसका cube है, that's good. But अगर नहीं मालूम तो we can always do the prime factorization. So if I do the prime factorization over here, it is 343 I cannot do it with 3 nor 5. I can try with 7. So 7, then 4s are 28, and yeah, so 63, 9. So that's it, 7, 7, 7, 1. So that's why A is equals to 7 centimeter. So that will be the length. So it is given as the length of the edge. So length is equals to 7 centimeter. So that's the answer for sum number 1. We now move on to sum number 2. The first one of sum number 2. They are given as the data is directly given over here. So they are given here the volume is equals to, it's a cuboid with the volume given to you as 90 centimeter cube. They are given the breadth is equals to 5 centimeters and the height is given as 3 centimeters. So we know very well the volume is equals to length into breadth into height. So 90 is equals to length into 5 into 3. Okay, we are just substituting the values of these VL. So in the equation, we know that this is the formula of volume. The volume of a cuboid is given by length into breadth into height. So because it is length into breadth into height, I am just substituting the values. So accordingly, what will happen? The ये नीचे चला जाएगा, so it will be 90 upon 5 into 3 is equals to L. So you can do the cancellation. 3 ones are 3 30s are, and 5 ones are 5 6s are 30. So therefore length is equals to 6 centimeters. So that's the answer for the second ka first. Are we clear with this? Okay, we move on to the next one. We move on to sum number second ka second. So that will be the second sum. They are given us the length, breadth and height of the cuboid. So it's given that length is equals to 15 centimeter. The breadth is equals to 8 centimeter. And the height is equals to 7 centimeter. So we need to find out the volume. Volume is equals to L into B into H. So that gives me as 15 into 8 into 7. So 15 into 8 is 120. So it is 120 into 7. So 7 is 84. So 840 centimeter cube will be the volume. So volume is equals to 840 centimeter cube. Very, very easy. You just have to multiply them. Nothing at all. Nothing to change or just find out directly. We move on to sum number second ka third. So third sum. They are given as the volume to be equal to 62.5 meters cube. They are given the length to be as 10 meters. The breadth is given as 5 meters. Accordingly, we know that volume is equals to L into B into H. So 62.5 is equals to 10 into 5 into H. Accordingly, you get that 62.5 upon 10 into 5 is equals to H. Now I don't like the decimal point over here, so I'll just remove the decimal point. How do you remove the decimal point? So it will be 625 upon 10. That will make you 62.5 into 10 into 10 into 5. Okay. So now I know that if I divide this by 5, so 5 will be 125 is equals to H. So I got over here that H is equals to 125 upon 100, which is nothing but 1.25 meters. So that gives me the height to be as 1.25 meters. Even if you are not taken this as, it doesn't matter. You can always make this as 12.5 upon 10. So yeah, I just made an extra step of converting 62.5 to 625 upon 10. Yeah, it is just for convenience. So whatever is comfortable to you, you can do the calculations in your way. Not a problem at all. Okay, we now move on to sum number 3. Okay, so moving on to next sum, that is sum number 3. Find the height of a cuboid whose volume is 312 centimeter cube and base area is 26 centimeter square. So let's write the data first. So data is given as third sum, volume is equals to 312 centimeter cube, area of cross section or base is equals to 26 centimeter square. So now since the area of the base is given to me, that means length into breadth is already given to me. So I don't have to take L into B at all. I just have to say area of the base into height. So I'll take the next formula. The formula over here will be, so we see that we had two formulas. One formula was V is equals to L into B into H, and the other formula was V is equals to area of base into height. So this is the formula what we are using here. So your formula will be V is equals to area base into height. So it is 312 is equals to 26 into H. So therefore 312 upon 26 is equals to H. So you can do the cancellations. This is 13 and this will be 1 and then 5 and 6, 156, and then 13 ones are and then 2s are 12s are. So that's why H is equals to 12 centimeters. So this gives us the height of the cuboid will be 12 centimeters. Okay, very easy sums, absolutely easy, nothing confusing at all, right? So let's see the sum number 4. Moving on to sum number 4. A go down is in the form of a cuboid of measures 56 meters, 45 meters and 30 meters. So whenever they are giving us the dimensions as 55 meters into 45 meters into 50 meters, that means the length is 55, breadth is 45 and height is 30 meters. Okay, so it has given us that the so cuboid with length is equals to 55, breadth is equals to 45 and height is equals to 30 meters. Now you got how many cuboidal box, okay, how many cuboid box can be stored in it if the volume of one box is 1.25 meter cube. So you know that the go down is a room, okay, the go down is a room, and in that room you are going to place boxes which are of 1.25 meter cube volume. So if I want to find out that how many boxes can be accommodated in that go down, what I need to do is a simple formula over here that, okay, we have over here, this is cuboid go down, another is volume of one box is 1.25 meter cube. So number of box is equals to number of boxes is equals to volume of go down upon volume of one box. Okay, it's a very simple thing. You know, if you have a room और रूम के अंदर हम लोग अगर समझो एक बॉक्स रख रहे हैं तो कितना होगा, एक बॉक्स फिर ऊपर फिर ऊपर फिर ऊपर, तो वैसे करके पूरे वॉल्यूम को हम लोग अगर एक बॉक्स के वॉल्यूम से डिवाइड करेंगे, you will get the number of box which can be placed in that, right? Like suppose you take a small box और उसके अंदर हम छोटे one you got one let's say a box is there और वो बॉक्स के अंदर छोटे छोटे और बॉक्सेस रखने हैं, तो क्या करेंगे हम लोग, बॉक्स रखते जाएंगे and we will see to it that it is accommodating the complete volume properly. So the volume of the go down upon volume of each box will give you the number of boxes which can be accommodated inside that particular go down. So accordingly what will happen is this is equals to 55 into 45 into 30 upon 1.25. Now again, I don't like this point, decimal point over here. So what I'll do, I'll write it as 55 into 45 into 30 into 100 upon 125. Okay, because 1.25 will be 125 upon 100. So 125 ka 100 upar chala jayega. So if I do the cancellation, it will be this way. 25 4s are, 25 5s are, and then 5s are, this will be 11s. Okay, so this gives us as equal to 45 into 11 will give you 55 and 44, 49, 495, and this multiplies to be 120, so into 12, so 12 5 is a 60, 12 9 is a 108 plus 8 plus 6, so 114, and 12 for 48, 58 and 59. So that will give me 59400 boxes. So the number of boxes which can be stored in this will be 59400. Okay, I'll just cross check the answers also so that we are sure that we are not making a mistake in calculations. So accordingly, yeah, it is 59400. Okay. So that was the sum number 4. We now move on to sum number 5. A rectangular pit 1.4 meters long, 90 centimeters broad and 70 centimeters deep was dug, and 1000 bricks of base 21 centimeters by 10.5 centimeters were made from the earth dug out. Find the height of each brick. Okay, so now this is a slightly tricky one. First of all, what we did, they wanted to make bricks. Okay, they wanted to make bricks. So what are the dimensions of bricks? 21 centimeters by 10.5 centimeters. यानी 21 centimeter, 21.5 centimeters, 10.5 centimeters. Height नहीं मालूम. Height उन लोग ने बता नहीं. उन लोग ने इतना बताया सिर्फ कि they have made 1000 such bricks. Okay, they have made 1000 such bricks over here. But for making these bricks, they dug up a particular soil, or dug up the earth to get that particular soil for making the bricks. And they are given us that what is the dimensions of the pit which was dug up in the ground. So जो dig किया हुआ जो pit है, उसका volume or volume of the total bricks which were made will always be the same. Right? क्योंकि हम लोग ने क्या किया, यहाँ से मिट्टी निकाला, उसको छोटे 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 boxes में बनाया, and we made into 1000 bricks. So that means the complete volume of the soil got converted into bricks. Right? So first of all, what we have is that volume of soil, or we can say earth, because they are given you as earth, because pit was dug. Okay, earth dug, yeah, earth. So that is volume of the earth dug is equals to L into B into H, which is nothing but it is given as 1.4 meters into 90 centimeters into 70 centimeters. So because everything is in centimeters, I will convert it into 140 into 90 into 70 centimeter cube. I am not multiplying right now because I am going to do the cancellations over here. Okay, I will be required to do some cancellations. Now I know that what is the volume of 1000 bricks, or we can just say that okay, we now know that volume of earth dug is equals to volume of 1000 bricks. Okay, so whatever is the volume of the earth dug is equals to the volume of the 1000 bricks what we have made, right? So that's why we write over here the volume of dug is nothing but 140 into 90 into 70. And what about the volume of the bricks? Now it is nothing but 1000, because 1000 bricks are there, into L into B into H of the bricks. Okay, so it will be 140 into 90 into 70 upon 1000 कर लेते हैं तो क्या easy पड़ेगा. और यहाँ पे L is known to me as 21.21. Okay, this is 21 into 10.5 into H. I know L is 21 centimeters, breadth is 10.5 centimeters, and height is we need to find out. So ये तो सब cancel हो जाएगा. तीनों zero cancel हो गए. So now it is 14 into 9 into 7 upon 21 into 10.5 is equals to H. So this 7 ones and 7 threes are, 3 ones are, 3 threes are. Okay. You can do the cancellations here also, but or else I will just make it easier. So I know now it is 14 into 3 into 10 upon 105 because it is 10.5. So 105 हो गया ये. So 5 twos are and 5 21s are, 7 threes are, 7 twos are, 3 cancels. So therefore H is equals to 4 centimeters. So the height of the brick is 4 centimeters. Did you understand this particular example? What we did over here was that we found out the volume of the soil which was dug out from the earth. That volume was used to make 1000 bricks. So that for volume of the earth dug is equals to volume of the 1000 bricks. Now volume of each brick is nothing but small LBH, where L is 21, B is 10.5 and H is just H. I need to find out. So automatically volume of the earth dug is this much. Divide by 1000 will give you the and this where each brick का volume. तो each brick का volume को साथ में हम लोग divide करेंगे तो you get H is equals to 4 centimeters. So this is a simple calculations for this particular sum number 5. We now move on to sum number 6. Sum number 6. If each edge of a cube is tripled, then find how many times its volume becomes. So what we'll do is that we'll take the wall. Okay, we'll say that let initial length be x. Okay, if the initial length is x, therefore initial volume is equals to side cube is equals to x cube. Okay, we can take it in centimeters. So it is centimeter cube. Now what are they told us? They are told us that we are tripling. Okay, we are going to triple the cube ka edge. So each edge, each length of the cube is going to be tripled. So we can say the for new length is equals to 3x centimeters because we are tripling it. Therefore new volume is equals to 3x the whole cube is equals to 27x cube centimeter cube. So you can see that between this and this, what is the ratio? Therefore we can say that new volume upon initial volume is equals to 27x cube upon x cube. So therefore it is 27 times more. Okay, so the new volume is 27 times the old volume. Got it? अगर इसको इधर भी लिखेंगे तो भी वही होगा. New volume is equal to 27 times the old volume. Okay, we can write over here new volume is equal to 27 times old volume. So they asked us that how many times will the volume become? It will become 27 times. Okay, the volume will become 27 times. That is sum number 6. We now move on to sum number 8. Sum number 8. A closed box is made up of 2 cm thick wood with internal dimensions 84, 75, 64. Find the volume of the wood required to make the box. Okay. Fine. So let's understand this question properly. I'll just erase this because I'll just not do it right now. A closed box. Now what is the meaning of a closed box? Suppose I take a box like this. Now in this box they are given us that the dimensions of the external dimensions are 84, 75 and height is 64. Okay. They are given that the thickness is 2 cm. That means if I draw the inner part, यानी इतना पार्ट जो है, that is the thickness of the box. So the thickness of the box is given to you as 2 centimeters. This is 2 centimeters. This is 2, this is 2, this is 2 and this is 2. Same way for the height also. The height also there will be 2 centimeters because the height will also be, अगर अंदर से देखेंगे तो वो भी नीचे भी उतना thickness मिलेगा. This is also going to be 2 centimeters. Over here it will be 2 centimeters. Over here also there will be 2 centimeters. So accordingly what will happen is that if my length is equals to 84 centimeters and then my small l, that is, this is, okay, we'll take it this way. I'll do one thing. Let's see that what will be the internal and external dimensions be. So if we talk about the dimensions, we have got over here, this is external and this is internal. Now what is internal and external? I hope you understood that अगर मैं कोई बॉक्स लेता हूँ तो बॉक्स का थिकनेस को छोड़ के अंदर का जो पार्ट है, that is the internal volume. So internal volume is this part. This is the internal volume. Okay, whereas जो wooden part है, wooden part is this part. This is the wooden part. This complete thing is the wooden part. ये part, ये सब wooden part है. This is the wooden part. Okay, the outside part, that is the wooden part. So if I want to find out कि wood कितना use हुआ, तो हम लोग को क्या करना पड़ेगा? External volume minus the internal volume. Internal volume क्यों? Suppose it is this way that I am considering that it was completely wood. Okay, पूरा wood से ही बना था. There was no box at all. It was just a cube. Okay, it was just a cuboid which is completely made up of wood. और फिर मैंने अंदर से wood निकाल दिया. I made it empty with some thickness over there. Then what will happen? जितना मैंने निकाला वो क्या था? That is the internal volume of the wood. Okay, box की internal volume जो है उतना मैंने निकाल दिया. So then what is remaining? The remaining is the wooden box itself. So I can say that the volume of the wood used will be equal to the volume of the external box minus volume of the internal box. Now for this what will require is that first of all this will be L will be equal to 84 centimeters, whereas the small l over here will be 84 minus 4 is equals to 80. Now why 4? Because if I see the length over here, ये लेंथ 84 है, उसमें से यहां से 2 सेंटीमीटर यानी यहां से 2 सेंटीमीटर कट हुआ फॉर द थिकनेस और ये 2 सेंटीमीटर थिकनेस कम हुआ यानी अंदर से अंदर. ओके, यू कैन सी ओवर हियर, यू कैन सी इजीली ओवर हियर दिस पर्टिकुलर ये जो रेक्टेंगल है इसमें द आउटसाइड इज 84 बट द इनसाइड विल बी 80 बिकॉज 2 फ्रॉम हियर एंड 2 फ्रॉम हियर गॉट कैंसल्ड. द थिकनेस ऑफ द वुड गॉट कैंसल्ड, सो ऑटोमेटिकली 84 यहां से है पर यहाँ पे कितना है 80 हो गया, so that will be 80 centimeters. Similarly will be the width is 75, so this is 75, this distance is 75. यहाँ से 2 गया तो ये कितना हो गया 71, so that's what we are writing. B is equals to 75 centimeter, whereas small b will be equal to 75 minus 4 is equal to 71 centimeter. Okay, the next one is the हाइट में भी वही होगा. हाइट में यू कैन सी ऊपर के टाइप में देयर इज अ बॉक्स के ऊपर का ढक्कन जो है वो 2 सेंटीमीटर का रहेगा, नीचे से भी 2 सेंटीमीटर थिकनेस रहेगा. सो आउट ऑफ 64 2 सेंटीमीटर गो हियर एंड 2 सेंटीमीटर गो हियर. सो अकॉर्डिंगली द इंटरनल एरिया ओवर हियर विल बी 60. So that's why height will be equal to 64 centimeters, whereas h will be equal to 64 minus 4 is equal to 60 centimeters. So we now know that we need to find out the volume of the wood. So volume of wood is equal to volume of external, or we can write it external volume minus internal volume. External volume minus internal volume. So that will give me 84 into 75 into 64 minus 80 into 71 into 60. Okay, we don't have a choice but to just multiply this thing as it is. So it will be 84 into 64. So 4 4s are 16, 32, 33, 0, 6 for 24, 2, 48, 50. So that will be 6, 7, 3, 5. So it will be 5, 3, 7, 6 into 75. That will give me 7 5 is 30, 7 7 35, 36, 37, 38, 15, 16, 17, 18, 25, 26, 0, 742. So 749 plus 4 is 53, 721 plus 5 is 26, and yeah, 35, 36, 37. So that will give me 0, 0, this will be 9, 10, 11, 12, 13, 10 and 4. So that will give me as 403,200 minus. So on the other hand, you have got the multiplication of this one as 71 into 48. Yeah, 8 into 4 is 48. So 48. So 8 ones are 8, 56, 0, 4 ones are 4, 28. So it will be 8, 0, 9, 14 and 3. 304. So it will be 30340800. So you subtract them and you get over here 0 0 to मिल ही जाएगा. 8 over here and 2 over here, so 12, so 4, so this becomes 2, then 2 will remain as it is, and then it is 10, so 6, yeah, centimeter cube. So the answer to the question number 8 will be given as 62400 centimeter cube. That is the volume of the wood required for making the particular box. So volume of the book required to make the box will be 62,400 centimeter cube. So that is all these sums which you are having for the cubes and cuboids in the exercise. So yeah, that's it. So as I told you, you can just do the homework will be your solved examples 1, 2, 3, 4, 5 and finally it will be 9, 10, 11. So that's all for exercise 18.3. We continue for the next video in 18.4.